everyone. Welcome to today's presentation on SQL Server HA on Linux. We really appreciate you taking some time out of your busy days to join us, and we think the presentation will be worthwhile. My name is Josh Ochtmeyer, and I am going to be the moderator. Today's webinar is being presented by Microsoft and DH2i. We're very excited to have Mihaela Blindea on the line joining us from Microsoft. She is a Senior Program Manager for SQL Server on Linux and specializes in high availability in particular. And our other speaker will be DH2i's Connor Cox. Before we hear from our speakers, though, I just need to cover a few logistics regarding the presentation. All attendees will remain on mute throughout the presentation, but we highly encourage you to ask questions at any time using the GoToWebinar questions pane, and we will try to save a little time at the end to get those questions answered. But as the abstract alluded to, the first half of the webinar today will be led by Mihaela, and she will be presenting on content surrounding SQL Server on Linux and the different HA options that are available to you. And then we will transition into a more demo-centric presentation of DxEnterprise v17 software with Connor. But with that, I will go ahead and hand things off to Microsoft's Mihaela Blindea to get us started. So thanks for joining, Mihaela.
Thank you, Josh, and hello, everybody. Again, the goal of this session is to show a few of the high availability and disaster recovery options we have for SQL Server. We're going to focus on SQL Server on Linux, but same solutions are available on Windows as well. So let's start this by going through some background on why we have SQL Server on Linux and talk about the opportunities that led to enabling SQL Server on the new platform. Well, first we looked at the industry and we saw that businesses are more and more embracing a diversity of technologies in building their applications and solutions. Development and deployment environments included Windows, Linux, macOS, and Docker. We noticed also that the data was no longer just relational, with companies accessing diverse type of data, including video, streaming, documents, relational, both external data and internal to the organization. Also, languages and frameworks were also expanding with the popularity of Node.js, Python, Ruby, and so many others. In terms of deployment platforms, we noticed that companies deploy not only on premises but also in cloud or both for a hybrid solution in private or public cloud. And we concluded that we should make sure that SQL Server is an option in this diverse and competitive landscape. So definitely the market trend is toward choice. It's clear from what we see from Microsoft that we do deliver on choice, and we committed to this change. SQL Server on Linux is just the latest in a growing number of products that enable choice for customers. We have HD Inside on Linux, our server. You can run Linux-based virtual machines in Microsoft Azure as an infrastructure as a service option. Customers can take advantage of Microsoft-created database connectivity drivers or open source drivers that we contribute to as well to enable developers to build any application using any platform and tools of their choice, including, as I was mentioning earlier, Python, Ruby, Node.js, Java, and so on. Moving forward, the private preview, so once we decided to go ahead and have SQL Server on Linux, the private preview announcement was sometime in spring 2016, and the momentum created then proved one more time the huge market demand for SQL Server on Linux. SQL Server was the only RDBMS at the time in the Gartner Magic Quadrant without support for Linux. And the community reaction to the announcement was super positive, with thousands of applications for private preview. And moving forward, the huge interest continues throughout the public preview as well. Only in a few months we released 7 CTPs, and we looked at our telemetry and we understood that there are more, for example, there are more than few months back, there were more than 1 million pulls. Recently we hit actually 2 million Docker pulls and trial downloads, as well as tens of thousands of active instances across all distros. So one note I would add here is that active is not only, we're not looking at an active instance as a running SQL Server engine, but we also consider the instance being active only if a key differentiator feature are actually being used. In terms of where SQL Server is running, so SQL Server is going to run, obviously, the new version 2017 is going to run obviously on Windows, but also on various Linux distros. We're planning for formal support for Red Hat Enterprise Linux, Ubuntu from Canonical, as well as SUSE Enterprise Linux. But you can run it in many other distros as well. Even more, with Docker support, you can run SQL Server on a lot more platforms like Kubernetes and Docker Swarm, Mesosphere, DCOS, Pivotal, and so on. As I've mentioned earlier, our goal is to get SQL Server running everywhere and let customers run whatever they choose to. In order to deliver same capabilities, so moving on to the features that are available on the new platform, we understood that from the very beginning that there are a few areas we need to focus on. I'm showing here the principles we applied when it came to prioritizing one feature versus another. For example, we have performance as this was and continues to be a top priority for us. For example, we already published a TPCH benchmark performance result on Red RHEL, and we show that the results for that specific workload were better than SQL Server 2016. Customers are still pleasantly surprised nowadays that they can just take a backup from Windows and restore it on Linux, or that they can set up always-on availability groups cross-platform. It just works, and that talks to our cross-platform compatibility. We just run the same SQL Server on both platforms. And in terms of user experience, while we delivered an enterprise-ready product from capabilities and features perspective, we did not forget that we are in a different environment, right? And from installation experience or tools to integration with other cluster technologies, we considered that a native user experience was equally important. So we invested in all these areas. Now, looking at the next level of details, right, from features to specific features that we're talking about here in this session, a lot of customers are asking what features are available, and in terms of HADR capabilities, what solutions are available on Linux. In general, for this release, everything within the scope of database engine is included. While services like analysis services or R reporting services are not in SQL Server 2017 on Linux, almost all of the features with database engine should be there. We believe that this will enable SQL Server to deliver a consistent data platform across Windows Server and Linux, as well as from on-premises to the cloud. And drilling further down on the specific topic on HADR capabilities, our goal for SQL Server on Linux was to enable all organizations to achieve a broad range of availability SLAs. And the idea was to accommodate various business requirements in that sense. Well, we're using this frame to categorize the solutions that are available on both Windows and Linux. In the simple HA category, we have organization can leverage virtualization technologies to achieve a higher degree of resiliency against host level failures, fault tolerance against hardware failures, as well as elasticity, resource maximizations with use of virtualization environments. This system can run not only on premises, but simple HA solutions apply to SQL Server running on private or public cloud or even hybrid environments. In terms of DR, the fundamental form of disaster recovery and data protection is the database backup. The next set of solutions are part of the standard HADR. They focus more on instance level protection combined with reliable shared storage infrastructure. Our database level protection with always on availability group support is available on standard as well. For DR, once the baseline data protection is in place with the backups, the rest of the environment can be customized to the needs of the organization for additional disaster recovery. And one such option is, in the case for standard DR, is log shipping. For mission-critical SQL workloads, we have always-on availability groups as an integrated solution that provides redundancy within or across data centers to help enable fast application failover during planned or unplanned downtime, with definitely with no data loss. We talked a little bit about why we have SQL Server on Linux. We talk about what solutions are available and what features are available. I want to focus next on how the HADR solutions were implemented in Linux. We all know that in order to achieve higher availability SLAs, we need a cluster to coordinate the automatic failure detection, to coordinate the automatic failover, in case of failures that can cause application unavailability. In Windows, for example, SQL Server relies upon the operating system to provide the infrastructure and the features supporting both failover clustering as well as always-on availability groups. Windows Server Failover Cluster is one of the clustering solutions that customers can use to integrate with SQL Server high availability features. Similarly on Linux platforms, SQL Server is natively integrated with Linux clustering solutions like Pacemaker to enable the same set of HADR scenarios. But one important design consideration that I want to bring up here, and the reason we talk about it right now, is that while in Windows, SQL Server is tightly integrated with Windows Server Failover Cluster, and workflows like failover, for example, are built on a communication layer that goes both ways, from SQL Server to the cluster and vice versa. For Linux, we choose a different approach, both for shared disk failover cluster and availability group solutions. SQL Server is what we call it is not cluster aware, and it is managed by the cluster orchestrator in an outside-in manner. The APIs used to integrate are, are public, the SQL APIs, and such that customers and our partners can also integrate with the other cluster technologies. And this is, this leads us to DxEnterprise solution. We're going to hear from Connor next on the experience they built to integrate their cluster solution with SQL Server on Linux. And not only that, right, it's available on Windows as well to build a highly available database system.
Great. Thanks, Mihaela. Appreciate the introduction there. My name is Connor Cox with DH2i. DH2i, if you haven't heard of us, it's a company that's been around since 2010. DxEnterprise is our flagship product. And what it is, as Mihaela was mentioning, is that it's a third-party clustering solution. And so we've been doing this for a while now. We've got customers and partners really around the globe. And we've got customers that have been running our Windows product in production since 2011. So everywhere from kind of medium-sized companies up to enterprise-size global 500 type organizations. So certainly not new to this, but what is new that we want to talk about today is our V17 release. Okay, so this was just recently released, and what this added was support for Docker containers on both Windows and Linux, and then support for the Linux platform. So again, before really focused on Windows, but now we're adding support for Linux as Microsoft has gone in that direction with the SQL Server product. Okay, so we've definitely seen a lot of those same trends where customers are looking for that flexibility, that agility of being able to manage hybrid environments or just having that additional choice of what platform they want to run on. So on the next slide, what we're going to do today is go through a demo of DxEnterprise. So just want to be able to show this to you guys. Build a 2-node cluster, and then once we've done that with a couple of different Linux nodes, we are going to manage a SQL Server instance, show how we can make it highly available. And so what we'll do is we'll demonstrate failover with it. We're actually just going to reboot a node and then see what happens to the instance. And then we will do something very similar with a Docker container. Okay, so we're going to take a Docker container and actually make it mobile or between hosts with disk data persistence. Okay, so that's very crucial when you're talking about Docker. People are trying to solve that issue of how do I move a Docker container and maintain the data, right? Maintain state. So once we finish that, what we're going to do is just quickly jump over to show a connection to a DxEnterprise on a Windows cluster, so you can kind of get a sense for what that would look like managing a hybrid environment. Maybe you've got some Windows already, SQL Server on Windows already, and you need to add in some high availability for your Linux deployments, so you can kind of control them both from the same cluster manager. So, so with that, I'm going to go ahead and show my screen here. So just let me get this pulled up, and we will get going on a demo. So let's see here. All right, so let's go ahead and get started here. So what we're first going to do is connect to one of my Linux nodes. Okay, so this happens to be a Red Hat node. Let's go ahead and log on here. So we're connecting from a Windows Server node, and we're just going to go into this Downloads folder and install the DxEnterprise package. Okay, so this is just a very lightweight package. It's just an application here that we're going to install on this Linux node. So, so we've done that. The next piece here is we need to go ahead and set a passkey for our cluster that we're going to create. Okay, so let's just go ahead and do that command here to set a passkey. So it's going to prompt us and ask us if we're sure we want to do that. We'll say yes. We'll go ahead and enter our passkey. And now we are all set there. So the next thing we're going to do is launch the UI. Okay, so this UI is, we're running it locally from our Windows machine. Okay, so it's called DxAdmin. This is what we can use to manage our cluster, our Linux cluster, or our Windows cluster, right? This DxAdmin client can be installed on any client machine that is running Windows, so Windows Server or a desktop workstation or laptop or what have you, we can install this tool. So we're going to go ahead and then just connect to our node that we just installed, right? So that was the .122, and then enter our passkey. Say yes, we do want to connect to it, and then now we need to activate this machine. So this is our node, our rel1 node, right, that we just installed, and it needs to be activated for DxEnterprise. So what I'm going to do is hit activate, paste in my license key, accept the EULA down here, and then hit activate. Okay, so this is just going to go out, activate it. So again, this is just sort of our baseline setup for this node, installed and activated. And we can see, if we click on the Red Hat node here, we can see some various information about the node itself. Okay, so essentially what we have is a one node cluster. And so let's go ahead, and what we want to do now is add another node. Okay, so let's open up another connection. And this one happens to be an Ubuntu node. Okay, so something that's kind of interesting about this product is that it is really agnostic to the platform that you're running it on. Okay, so you don't have to have this sort of like for like type restriction. You can actually mix and match various distributions. So from what we
add a Windows node, Connor?
Yeah, so that's a good question, Mihaela. You can absolutely add a Windows node to this cluster. Again, we really don't care. But you would just run into whatever restrictions there are for the application that you're trying to manage in terms of failover. So you wouldn't be able to, for example, fail over a SQL Server instance from Windows to Linux or vice versa. Right, there would be some other steps there because of the differences between the instance itself across platforms.
I guess it's about how you configure the instance on one platform versus another.
Right, absolutely. Yeah. So yeah, and that's a good thing to bring up, right? Because people are looking for a solution that can manage multiple different applications, multiple different platforms, right? So this kind of bridges that gap there, but we certainly will run into application restrictions, just how certain things are architected. Okay, so let's go ahead and log in here. This is our Ubuntu node. Curious, Mihaela, do you see people from the clients that you talk to wanting to run a mixed, I guess, Linux flavor cluster? Is that something that you see? And if so, kind of what's the use case that you typically run into?
Mixed in terms of Linux, right? Not necessarily. I get the question. That's why I asked earlier if you can put Windows nodes. So I get the question about mixing the platforms. Mixing distros come into place when customers will want to change their infrastructure, or they want to test, right? We know that Ubuntu has a free flavor, and it's easier, and they just want to move over the data, for example. Migration testing, it comes up a lot. I can see it in cases where there is a security risk and I want to move to a distro that doesn't have a specific security bug or something like that. So it comes up, and customers do ask about some mixed platforms and mixed OS scenarios, definitely.
Yeah, definitely, and that kind of jives with what we're seeing. We don't typically see people that say, yeah, I just want a mixed cluster just to run in production ongoing, but they are kind of some of those cases of, okay, I need to move from here to there for one reason or another.
Yep.
All right, so what we're going to do now that we've connected to this Ubuntu node is basically do a very similar process. But the first thing we need to do is actually install the DH2i version of the Mono library. So we're going to get into that same downloads folder, and then go ahead and install that package. And then once we're done with that, we will also install DxEnterprise on this node. So just enter the password here for that package, and then do the installation for DxEnterprise itself. All right. And then once that's completed, we are going to join it to the Red Hat node. Okay, so we'll use that same DxCLI command and then say join cluster. So this is what you would do anytime you're adding another node to the cluster. You just want to install and then join to one of the other nodes. So we'll say yes, and then enter the IP address of that server that we're joining it to. So this will be the IP of our RHEL1 node. And then this is where we're prompted for the passkey. And then should just take a moment to join, grab that configuration. All right, so that's done. Let's go back to DXAdmin. And now we can see we've got our other node that's added. Now it's red because we need to activate the license on it. Okay, so we'll go into advanced cluster membership, manage the license, and then just add that same license key here onto our Ubuntu node. Okay, so all the nodes need to be activated for DxEnterprise. So we'll just do that. Okay, and just close out of these. Okay, so everything's green, right? I can see both of these nodes here. I can click on them so I can see different information about the Ubuntu node and the Red Hat node. Okay, so this is just two-node cluster. That's what we're going to build. And what we're doing here with the DxEnterprise product is we are doing shared disk clustering. Okay, so I know there's a lot of talk about availability groups. It's a really cool technology, but from what we're seeing is that there are a lot of customers out there that do actually want that instance level shared disk clustering and not availability groups. And so that's kind of the niche that we fill right now. Mihaela, do you see that kind of split as well with your customers and the clients that you speak to, and why are people going one direction or another?
Sure, we definitely have a high demand for both solutions, and that's definitely one of the reasons that we have supported on the new platform as well, right? We looked at our customers' demand and we looked at the usage on Windows. We did some research within our private preview customer group, and definitely both solutions came up. In terms of what customers prefer, which one, it will depend on their SLA requirements. It will depend on cost, right? And in the high availability groups case, you have the extra cost of the additional replicas running SQL Server, right? Comparing to FCI, and it's about the scenario that it addresses, right? In one case, I have a database level protection. If you want like application level protection, in the other case is an instance level, and it removes some of the burden of that in availability groups we have everything is replicated that it is within the database, but instance level objects are not. So it will highly depend on what customers scenario they have and what the cost they want to invest into that. And as I was saying, it's both. I don't think we have customers that are moving from one to another once or to the new one, right? To availability groups. It's spread across.
Yep. Yeah, makes sense. Makes sense. So with that said, what we need to do is manage some disks, right? Because we've got shared disks, shared disk clustering, and so we need to manage some disks. So we have a storage manager that's built into this tool, and so I'm going to just go ahead and allocate some cluster shared disks, for our data to be able to reside for a SQL Server instance. Okay, so it's up to you how you want to present your disks. What we've done is we have presented some iSCSI disks to both of our Linux nodes. So what that allows us to do is to use our storage manager, manage some storage, right? Manage one of these disks. And then once it's managed, that allows us to create a volume on it. So we create the volume, and then we can format it. Now when we format, we do have a variety of different file systems to choose from. These are the file systems that the guests, that the nodes support, right? So you can pick from there. Also pick your block size, so that's up to you as well. I'm just going to leave these as default here, so we can just create this this volume. And then finally, we want to set a logical drive for it. Okay, so this is going to be the mount path, right, that we use to access this data. So I'm just going to put it on mount DXE and then call it disk 10 in that folder and submit. Okay, so that piece is done. We've managed this disk. The next thing we're going to do is create what's called a virtual host. So virtual host, what is it? A virtual host is really a logical host abstraction, and we use this to enable that consistent application endpoint. So whether your instance is running on the Red Hat node or the Ubuntu node, you need to be able to connect to it, and clients need to be able to connect to it via that same connection string. Okay, so that's what this really enables. So all it consists of is a virtual name and virtual IP address. So I've already set those name and IP address pairs aside, so what I'm just going to do is enter those in here. .125, and then basically it's saying which nodes do we want this vhost to be able to run on. So we'll say first start it up on the Red Hat node, and then it will go on and fail over onto the Ubuntu node. And then if I had more nodes, those other ones would be added as backups as well. Okay. So we'll just hit OK. And so what this does is it goes out and creates this entity, and essentially all it does is it binds this vhost IP address, this .125, it binds it to the active node. So in this case, this is our rel1 node, and we can see that our IP address is indeed bound on that node. So when we move a vhost, we just move an IP address. It's really that simple.
And that is built in, right? A customer doesn't have to add additional configurations in order to make sure that, when the active instance moves to the other nodes, the IP will follow, right? This is
exactly. Yep, you got it. So it's all built in. And once we do a failover, I'll kind of walk you through what is happening when we initiate a failover. But that is one of the steps that is all automatically built in. So good question. So now we've got our vhost. What we're going to do is manage the disk group associated with this vhost. Now, what does this mean? This means that wherever this vhost is active, the associated disks will be presented as read-writable to that active node. Okay, so what we're going to do is we're just going to select the volume that we just managed, and now it's over on the selected side, and just hit submit. Okay, so as part of the failover, we will also move the disk or present it and make it active on the node that's active. And that's another part of the failover process that is automated and just happens when an instance moves, whether it's manual or automatic. Okay, so we've got our vhost, we've got our cluster disk. The next piece here is we're going to add a SQL instance. So in order to add a SQL Server instance to a vhost, we need to do a couple of things. First, we need to ensure that the instance is installed locally on any of the cluster nodes that we want to be able to run that instance. Okay, so that is a prerequisite here. That's one thing that I have already gone out and done. I've just installed the latest version of SQL Server, and then I've installed and configured an instance of SQL Server on both of these nodes. Okay, so that has been done. What that then allows me to do is to pick this instance from the dropdown. Okay, SQL on Linux, we've just got the default instance, right, today. So that's the instance that we will select. I can give it any description, and then it will be on the default port, right? Because again, it's the default instance, and then we can enter the path for the data. So this is where the data is going to reside after I complete this process. This is where I want it to be. I want that to reside on the cluster disk associated with this vhost. So that's what I'm doing here. I'm just putting it in another folder called MS SQL Server. So the next piece here is we need to do our authentication. So we need a login and password here. So just enter that for the instance, and then we'll go ahead and click yes. So this process, what it does is it actually copies the data for the instance from the default path on the Red Hat node, copies it down to that cluster disk. Okay, so it just takes a copy and then puts that down on the cluster disk. We also have other means to be able to get your data there. So if you want to do a detach, copy, attach, you can do that as well. So then it won't actually do that copy as part of this adding an instance process. But since I had a pretty small data set, that was pretty quick, and it was able to just copy it down to the cluster disk. Okay, so click on the instance here. We can see some info about the instance. Okay, so I can see that it is indeed a 2017 RC2 instance. I can see some performance statistics of the instance. I can see other items here, the data path, etc. Okay, so that is done. So right now we are connected via the .122. So that is our Red Hat node. What I'm going to do is start a connection to this cluster via the .123 node. The reason is because we're going to kill the 122 node and see what happens. So I want to make sure that we can actually see what happens from a node that's going to survive. Okay, so we're just connected. It's the same exact cluster. You're seeing all the same things, but we're just looking at it through the Ubuntu node. Okay, so let's go down to the Red Hat node. First, actually, let's exit out from the Red Hat node, and then let's reboot it. Okay, so this is mad at me that the connection's gone, so we'll go ahead and just close that out, and then we'll watch. So we've actually detected that the instance is not active anymore, so we can see the instance turned orange. So we're going to initiate a failover. Okay, we'll also see the Red Hat node turn red. That means it's no longer available, right? And so what this is doing is it's making the Ubuntu node active. So what we're doing here is we're actually rebinding that IP address for the vhost. We are then presenting the disk to the Ubuntu node, making it active and read-writable there. And then finally starting the instance on the local binaries of the instance that reside on the Ubuntu node. Okay, so that's the failover process. Now, we can do manual failovers if you want to just say, hey, move this instance, start it on the other node. That's absolutely supported. But what we just saw was automated fault detection. Okay, we detected that the instance was down and that the server was down, and we took action and moved it to the next surviving node. Okay. By the way, same connection string as we talked about before, vhost1 MS SQL Server. So that doesn't change, which again makes it very nice from a client perspective. They see a brief pause because the service has stopped, and then the service starts back up and connections can resume. So that's really the first scenario I wanted to walk you guys through, taking an existing SQL Server on Linux instance, making it highly available. and across a couple of different distributions of Linux. Okay, next scenario, Docker container high availability. Okay, so for those of you that are looking at Docker or possibly are using it, one of the challenges of using Docker containers is providing high availability for the container and also doing so while persisting the disk. So ensuring that you have persistent disk when you fail the instance over onto, the container over onto a different host. So what we are actually going to do is add a container, start it on our Ubuntu node, and then manually fail it over, move it onto the Red Hat node. So they are completely different hosts, and the storage is in a third location, and we'll be able to move that container between hosts with persistent disk. Okay, so, well, the first thing we need to do is manage some more storage. So we'll go ahead and manage another disk because this is where the data is going to live for this instance. So all of these same steps which you've seen, creating the volume, formatting, and then finally setting that drive letter. Sorry, not drive letter, mount point, setting the mount point for it. So we'll just put this right next to that other volume here and click OK, submit that, and then another vhost. Okay, so we could add our container to our existing vhost, but then the container would fail over with the SQL Server instance. We don't want that. We want it to actually fail over independently. So we'll just provision another virtual host. This one's vhost 2. And then it has the IP address 200.126. Okay. We're going to switch up the ordering here, put Ubuntu first, hit OK. Right, and then once again, manage the disk group, bring that storage over that we just managed. All right, associating that with the vhost, and then what we have is a different selection here, add a Docker instance. So this is going to actually allow us to add a container. Now, we have a few pre-configured Docker container types that you can choose. So we've got SQL Server, MySQL, Mongo, Postgres, and then we've also got the ability to do a custom Docker container. So if it's not listed there, we can manage it as well. But what we're going to do is a SQL Server a Docker container. Okay. So first, we'll just give it a name. Pick Linux. And then the image. So one thing that we need to do is actually pull down the same image on both of our nodes. So both of the nodes associated with this vhost, Ubuntu and Red Hat nodes, they need to have the same Docker image. So in this case, we've got our latest MS SQL Server Linux Docker container. We'll select that, and that's the image that we'll be using for this container. We need to accept the EULA there. It's one of the settings, and then enter the port for the for this container. SA password. So we're setting that. Then the path for the data. So we want this to reside on our shared disk, right, associated with the vhost. Okay. We also have the ability to add any other optional parameters that you want to put down here. So that's others that you can add. There are some here, but we'll just leave this as is and go ahead and add the container. Okay, so very similar process to adding a SQL Server instance, but we're just doing a Docker container, SQL Server running in a Docker container. So that's added. It's pretty quick for containers. And now we can see information about the container itself. Okay, so we just pull all this information from Docker. And now what I want to do is show you how you can manually fail these over. So we'll go over to a different view here. This is instance view. I can see my SQL Server instance, where it's active and where I can fail it over. Also, I can go click on the Docker view. Okay, so I can see the name, the virtual host, the image, the port number, all of that relevant information. But what I can also do is initiate a failover. I can say, you know what, let's move this container and move it to the rel 1 node. Okay, so it's going to ask, are you sure you want to do this? And we'll say yes. So what this is doing is it is initiating a move of this container to a different host. So it's stopping that container, it's starting it on the Ubuntu node, it's persisting that disk, and we can always connect to it via the vhost name. Okay, so pretty cool stuff. You can see it's green here on the Red Hat node, indicating that it is indeed active over there now. Also, we have built-in HA for this. Just wanted to show you a manual move for this particular situation. Okay, so we can click on the container, see that it's still there. Everything is as it was before. Okay, so one last thing I want to show you guys. I know we're getting a little bit close on time. So the last piece here is our ability to manage Windows Server environments. Okay, so what I'm going to do is connect to a cluster that has Windows nodes in it. So this is a cluster that's also been built. So we'll connect to that cluster and show a cluster view of that. So what we see here is I have 12 SQL Server instances running across 4 different nodes. Okay, they are also mixed versions. Okay, so we can do mixed version of SQL Server clustering across the same cluster. And so we can see, again, four nodes, demo 1 through 4. And let's look at a little more information about those nodes. So demo 1, 2008 R2, demo 2, 2008 R2, demo 3, also 2008 R2, and then demo 4 is Windows Server 2012. Okay, so also have a mixed OS version cluster here. So pretty unusual from that perspective, in that we have a mixed cluster. So let's go back to the cluster view here, and the rest of the instances listed there. So again, this demo very focused on the Linux side, but also want the folks on the call to be aware we do have a Windows product, and it does a lot of other really cool things. So if you're interested in that or interested in the Linux piece, certainly reach out and we can talk some more. But with that, I think there are a couple other slides we wanted to hit. So Josh, could you do me a favor and go ahead and make Mihaela the presenter again, and we can cover those last couple slides with Mihaela presenting.
Yep, just a second.
So thank you, Connor.
Okay, Mihaela, you have control.
Yes, thank you. So all this was great. I just want to go through a recap. We in terms of the clustering options, we have Windows Server Failover Cluster as an orchestrator to integrate with SQL Server on Windows for both share this failover cluster and availability group solutions. On Linux, since Windows Server Failover Cluster is not available on the platform, SQL Server is integrated with the third-party cluster solution based on Pacemaker for both HADR solutions as well. But with the DxEnterprise, customers will get a multi-platform solution as it is available on Windows and Linux. You can build SQL Server instance level protection with shared disk. And one differentiator that was highlighted was the container support. So customers can include in their high available systems a SQL Server running in a container as part of their cluster configuration. So if you have a workload ready, you can go ahead and try the latest release candidate for SQL Server 2017. And similarly, you can try DxEnterprise V17 that has all these capabilities that we talked about. Now I'm going to hand it over back to Josh to see if there are any questions that are coming from the audience now.
Thank you, Mihaela. Yeah, we had a big group today, so definitely a list of questions we need to get to. But yeah, thank you, Mihaela and Connor, for the presentation today. And thank you, everyone who attended, for sticking around all the way to the Q&A and for your continued engagement, asking questions, and tuning in. But feel free, as we progress through the Q&A session, to ask any additional questions to come to your mind. And I'm pretty doubtful we're going to be able to hit the whole list with the time we have left. But you can rest assured that anything that is unclear or anything we don't get to by the end of this presentation, we will make sure to give you a call or send you a personal email to get those questions answered for you. But with that, obviously most of the questions for Mihaela got asked towards the beginning, and most of the questions for Connor got asked towards the second half of the presentation. But I'm going to try and keep both our presenters active and mix up the questions a little bit. So I'll start with one for you, Mihaela. This one you hit on, but just touch on again. Can I set up availability groups between Windows and Linux?
So the answer is yes, you can set up an availability group from Windows to Linux, but we need to also understand what is the goal of that specific setup. Well, as we mentioned earlier, there is no cluster solution that will support a cross-platform system like SQL Server running on Windows and Linux in the same time. So while you can set up availability groups cross-platform, that will not be a high available solution. You can set it up to migrate your data very quickly from Windows to Linux. You can set it up for testing purposes or even for DR, but for if you need automatic failure detection or automatic failover coordination, that is not there yet.
All right, thank you, Mihaela. And now one for you, Connor. How long does a DxEnterprise failover typically take to complete?
Yeah, that's a good question. So like we talked about before, we're doing a stop of the services and then starting the services. So it's really however long that takes. But typically what our customers report is that takes anywhere from 5 to 30 seconds.
All right, thank you, Connor. Great, so another question here for you, Connor, pertaining to part of your demo. So how come the mono package was not installed on the Red Hat node? Is this dependent on the distribution?
Yes, it is. So you basically answered it. That's just a requirement on the Ubuntu flavor, if you will, distribution, and that's not a requirement on Red Hat.
I guess we could just segue into what Linux distributions are supported on DxEnterprise.
Good question. So currently we have support for RHEL, so Red Hat Enterprise Linux, CentOS, and Ubuntu. We do have others on the roadmap, so we'll just kind of leave it at that, but more flavors are coming soon.
All right, thanks, Connor. And Mihaela, a question for you. Are there going to be any more SQL Server 2017 release candidates prior to GA?
At this time, we don't have a plan for releasing new release candidates. It's we're just waiting for the announcement. But we still don't have a date when we're gonna have the RTM builds yet.
And going back to Connor. Connor, another question regarding the demo. Can you do this in Azure or AWS without shared storage?
Yeah, so you can. So One thing I didn't really get into in the demo or the conversation was that DxEnterprise supports shared and or replicated storage. Okay, so if you do not want to do shared or you can't, you do have options. So essentially what we would look to is some means of replicating the data from server A to server B, and then we can then fail over onto, rather than the same disk, a replicated copy of that disk.
All right, thanks, Connor. And another question for you. Can DxEnterprise be used to fail over between Windows and Linux?
So that's a good question. So we kind of touched on that a little bit before. We can create a cluster of mixed OSs, Windows and Linux, but SQL Server can't stop on Windows and then start on Linux because of some differences. So if there is another application out there that can do that, we can certainly support it. But one thing I'll mention is that we can use this tool to help migrations be a little bit easier. And the way that you would do that is you would essentially present one of these LUNs to a Windows server, put your user databases on it, and then detach the databases, and then essentially present that disk to your Linux node, and then attach the databases. Okay, so it's something that you can definitely do with this tool because, as Mihaela mentioned, you can restore you can attach the databases onto the Linux version of SQL Server. So that's one that we can really just support out of the box. And what it does is it makes it so that you don't have to do any data migrations, right? You're essentially swinging that LUN to your target, to your Linux node, and then just attaching from there.
All right, thank you, Connor. And another question for you, Mihaela. I think we have time for a few more. How does licensing SQL Server in a Docker container work?
So it's pretty much the same thing as it works today in VM, right? So we look at Docker containers as the new VMs, if you want. So the licensing, it will be exactly the same. It will be core-based, depending on the number of cores and that are allocated to the container, or the number of cores on the host.
All right, thanks, Mihaela. Another demo question, Connor. When you add nodes to the cluster, is this prioritized based on the order selected/added?
Yeah, it is. So when I went and added the vhost, we got to pick the ordering as well as which nodes we wanted to select. So you get to choose at that point the priority, if you will, because the vhost and the instance, everything associated with the vhost will start on that first node listed, and then it'll fail over onto the next ones subsequently. So that's how you would set that. And then also, once you set it for the vhost, you can always go back and change it. You can remove a node from the vhost, you can add another node, you can reorder things. So you do have control over that as well.
All right, thanks, Connor. We're going to try and do one more question for you. What support options does DH2i have for their clustering product?
Sure. So we offer 24/7 support. It comes also with product updates. But what that means is if you have any issue with DxEnterprise, right, with the clustering product, we support that. So you can call us or email us, create a case, and we'll support it. If you have particular issues with SQL Server itself, then that's kind of more of a Microsoft question. So that's kind of where we would, draw the line, if you will, between the different support models.
All right, thanks, Connor. And thank you, everyone, for sticking around through Q&A. As many of you are well aware, we didn't have a chance to get to all the questions today, but we want to be respectful of your time and go ahead and conclude this thing. But as I said, if any of your questions were left outstanding, we will get you a personal email to get those answered. And as Connor and Mihaela mentioned, you can download the current version of SQL Server to try if you have any workloads ready for that. And there are also free trials available for DxEnterprise v17. And feel free to reach out with any additional questions to info@dh2i.com. But with that, thank you to our speakers. Thank you for all the attendees. And we are going to go ahead and sign off for the day.
Thank you.
Thanks, everyone.